Okay, so let's try out this example. Again, we're going to be using our powers of being able to express logarithms, logarithmic expressions differently in order for to achieve a specific purpose, which is to find the exact value of something that looks initially pretty complicated. Here we have, let's zoom in, log base 5. So the base is 5, and the input is a cubic root of 5. All right, so what can we do here? Well, one thing that we can do is let's actually change this radical notation to exponential notation because it is much easier to work with exponents rather than radicals in certain contexts, anyways. So the cubic root of 5 is really 5 to the 1/3 power. That's really just an exponent rule. Right, the let's go back here. The denominator of your exponent corresponds to the index of your root or your radical. So this would be 5 to the 1/3 power. Now, now that we've written this as an exponent, it might be clear that what we should do is take this exponent on our logarithmic input and to apply the power rule. Right? So let's write this as 1/3 times log base 5 of 5 now. And let's think about what log base 5 of 5 means. This really means, this expression here, or this logarithmic, this logarithm, really just means the number such that when we have base 5, when we raise base 5 to log base 5 of 5, we get 5. Or in other words, let's phrase it this way. Base 5 raised to what power would get you 5? Well, 5 to the 1 would get you 5. So what is log base 5 of 5? It's 1. That's the exponent that you would put on base 5 to get 5. So, so hopefully that logic is clear. And we can evaluate log base 5 of 5 as simply 1. There we go. So this is really just 1/3, and that's our answer. So this initially super complicated looking logarithm is really just 1/3. All right, let's take a look at this. Let's take a look at this next example here. So we have log base 3 of 3 plus log base 3 of, sorry, we have log base 3 of 3 to the power 7 plus log base 3 of 3 to the power 2. So let's just immediately apply the power rule in both of these cases here. So we have this input raised to the power 2. Let's apply the power rule. We have this input raised to the power 7. Let's apply the power rule. And move those to be coefficients in front of our logarithms. So this is going to be 7 log base 3 of 3 plus 2 log base 3 of 3. Right, we took this power on the input of our logarithm and we wrote it out in front. We took this power on the input of our logarithm and we wrote it out in front. Okay, so log base 3 of 3, so 3 raised to what power would be 3? 3 raised to the 1 would be 3. So, right, this is really just 1. 3 raised to what power would be 3? 1. So this is really just 2 times 1. Right, log base 3 of 3 is really just 1. So this is really 7 times 1 plus 2 times 1, which is 9. There you go. So this, a couple weeks ago, maybe this might have confused you, but hopefully it makes sense piece by piece as we go through the logic that this is really just a nice simple number. It's 9. All right, let's look at this next example. It looks quite awful, to be honest. So let's play around with it a bit. So here we have the logarithm of a fractional base. Great. And then the input of the logarithm is pretty complicated as well. It's 27 squared all over 3 to the minus 2 power. Where I might want to start here is actually in noticing that the inputs, we have a quotient of inputs here, but the numerator and the denominator can both be written in terms of powers of 3. So let's just do that, because if we can write all of them in terms of powers of 3, then we might be able to do some fancy simplifications. So 27 squared is really just, well, 27 is 3 cubed. So 27 is 3 cubed, and that's all squared. And 3 to the minus 2, actually what I can do here, so this is 27 is 3 cubed, all squared. And what I can do here is I can write 3 to the minus 2 as, if I have 1 over 3 to the minus 2, this is really just 3 to the positive 2. So because a negative exponent, to turn a negative exponent positive, you take the reciprocal of it. So here I've taken the reciprocal of this number, and I get 3 to the positive 2. Right? Maybe piece by piece. It might be more clear if I write it like this. 1 over 3 to the minus 2 is really just 1 over 3 all to the minus 2. And to turn this exponent positive, I just take the reciprocal of what's inside, which is just going to be 3 over 1, all to the positive 2 now, which is just 3 squared. Okay, so 3 to the minus 2 on the denominator just becomes 3 to the positive 2 on the numerator. So this is my entire input for my logarithm. This is why we had to get so comfortable with the exponent rules, because we're going to be playing around with them a lot. Now I'm going to simplify what's in the input a bit, because it's looking pretty crowded and complicated. 3 cubed all squared is just going to be 3 to the 6, right? Because if I have an exponent on the inside of brackets and an exponent on the outside of the brackets, I take their product. So 3 times 2 is 6. And that's times 3 squared. And then simplify again. It's going to be log 1/3 times, what's my input now? Well, I'm just going to take the sum of these two exponents. So this is going to be 3 to the, what is that? 3 to the 8. 6 plus 2 is 8. And then it's getting warmer and warmer out, so I feel like I'm thinking more and more slowly. So 6 plus 2 is 8. Yes, okay, good. So I'm going to apply the product rule to simplify this a little bit. So I'm going to bring this 8 down. And so this is 8 times log of 1/3. And 3 is now the more simple input. I'm actually going to make some room here. Let's think about log of base 1/3. What power could we raise base 1/3 to get 3? So when we are looking at log base 1/3 of 3, this is the question we're really asking. Base 1/3 raised to what power would get us 3? Well, we know very clearly that if we take the reciprocal of 1/3, we'll get 3. What's a clever way to write taking the reciprocal? Well, we could just write it to the -1 power. So, log of base 1/3, the logarithm of base 1/3 of 3 as the input, that should just evaluate to -1. So this is really just 8 times -1. So here, because log of base 1/3 of 3 is really just -1. I really just want to make this clear. This is really just log base 1/3 of 3, right? So 1/3 raised to the -1 power is 3. I feel like I'm just explaining the same thing again and again. The thing is, here I'm just acknowledging that logarithms are complicated, especially in the beginning. So I'm really just trying to make this notation as clear as I can. But as I do that, I might be making it more complicated than it should be. So 8 times -1 is just -8. So this initially really confusing logarithm, log base a third of 27 squared divided by 3 to the minus 2, is really just -8. It's a really simple number. But it takes some comfort with your exponent laws to rearrange the inputs here and to simplify, and then to have some degree of comfort with the logarithm laws or the properties of logarithms to know that you should apply the power rule here and write the 8 that was the exponent on this input of 3. And to write that as a coefficient in front of your logarithm. And then enough comfort with logarithms to be able to realize what this is really asking, right? This is really asking for the exponent that you would place on base a third to get 3. And that exponent that you would place on base a third to get 3 is -1. So this is really 8 times -1, which is just -8. So there's the end of that journey. And that's... Really, this just takes practice to get comfortable with, right? You have to be comfortable with all of these different properties of all of these different kinds of numbers. So in the next video, we're going to jump through just some more examples. We've really learned all of the logarithm properties that we should know by now, and it's just all a matter of developing a degree of comfort so that we can simplify problems that we are being asked of in workbooks, and then eventually, as you get comfortable with working through problems in workbooks, you can get comfortable working through real-world problems as well.